Hello, this is Hayden Call for my week 4 interview question. In reference to using linked lists with stacks and queues. To use a linked list with a stack implementation, you would simply just create the nodes as usual, and to add them to the linked list, you would just use the simple pop method, which would essentially, oh, excuse me, push method rather, which would essentially work as a add to tail um, uh, function if you built that out the long way in the code. We'll just add to the tail of the linked list. On the opposite side, if you're trying to remove items from your stacked linked list, the pop method will always just remove from tail. But doing it this way, they both work with constant time, so big O of 1. Also, if you're trying to get top, there's a built-in function with linked list to do dot count. That would get you the size of the array, or excuse me, of the linked list, and you can just simply -1 from that to get the index for that final piece of data. And then is empty could also run just through simple mathematics with the linked list. Both of those run also with constant time, big O of 1, to make that work properly. Queues naturally already work like a linked list in a lot of ways, in the sense that you typically pull stuff from the front of a queue and add stuff to the back of a queue. With that, it would be as simple as doing N queues would add to tail, and D queues would remove from the head. In both cases, typically N queues and D queues would work with a big O of 1. If you're working with something a little more complex and trying to do like a priority queue of some sort with a linked list, you would still be able to do that with a linked list by going through the items through a D queue. That would work with an O of N in that situation. Otherwise, size with that count method would work with a big O of 1, and is empty would also be a big O of 1. Linked lists to me would work really well with queues in my mind, just because they are so similar in the sense of being able to add information to the front, remove it from the back very seamlessly and efficiently, and much more efficiently than like a dynamic array. Thank you.